Okay, so this is my third attempt at this video. Let's pray that this one actually works. I'm going to make up an example just like number 20 using one of the do now questions that we had, because I don't want to take away your question from you. Number 20 is all yours. The first thing that it says use the fact that x minus 4 is a factor of the function f of x to factor this polynomial. Okay, so when something is a factor, that means that what we're doing division. Okay? So for part A, let's do our division first. This is the example that I pulled from the do now. So given that this is a factor, I'm going to divide it in. Now x goes in 2x cubed, 2x squared times. Distribute that down. 2x squared times x is 2x cubed. 2x squared times 2 is going to be positive 4x squared. Parentheses and subtract. If I move too fast, slow down the playback because this is my third time doing this video and I don't want to wait. Now, negative 3x squared minus 4x squared is negative 7x squared. Bring down the minus 18x. Now, x goes into negative 7x squared, negative 7x times. Distribute that over. You get negative 7x squared minus 14x, parentheses, and subtract. Cross those out. Minus negative 14 is the same thing as adding 14, so I'm going to change those to pluses. Now I'm going to get negative 4x minus 8. X goes into negative 4x, negative 4 times. Distribute that over. And I'm going to get negative 4x minus 8, which is exactly the same thing. They both cross out, and I get a 0 remainder. Well, duh. Of course I got a 0 remainder, because it's a factor. Now, they didn't just say, hey, this is a factor, divide it. They said factor using x plus 2. All right, remember, this is my imaginary example, because as I speak, you're going to try to match it up to number 20. This is a different polynomial. So essentially what they're saying is use this and this because they're equal to this. All right, so x plus 2, 2x squared minus 7x minus 4. And that's not fully factored. We want to keep going, okay? I would love it if this was just a simple a and m. What adds to negative 7 multiplies to negative 4. That's probably what you're going to get. But for this one, I happen to pick one in which there's a 2 in the front. So what that means is we're going to look at the coefficients a, b, and c. We're going to multiply a times c. Well, a is 2, c is negative 4, so that's negative 8. We're going to look for factors of negative 8 that'll add to negative 7. So let's see, for 8, I've got 8 times 1 and 4 times 2, and that's it. So I think that it's going to have to be 8 and 1. They got to add to a negative 7, so I'm going to put the negative on the bigger number. Negative 8 plus 1, yeah, that's correct. So it's going to be these guys. We're going to split the negative 7x. There's a lesson on this called factor by grouping. I think it's factor by grouping 3. So it's negative 8x plus 1x. I'm going to bring down the other terms. 2x squared minus 4. I'm going to factor this by grouping because now I have 4 terms. I can pull out a 2x, leaving me with x minus 4. On the right-hand side, there's no GCF, so I can just pull out a 1, leave me with x minus 4. Take your outside stuff, 2x plus 1, and your inside stuff, x minus 4. And all you have to do is bring down that guy from the beginning, and put that x plus 2 here. And this right here is fully factored. That's a cruddy box, but still fully factored. Now, that's great. That was part A. Part B asks you to find the x-intercepts, the roots, the zeros, to find those, and then draw an approximate graph. So here's what we're going to do. X plus 2, 2x plus 1, x minus 4 equal to 0. We're going to give ourselves a nice t-chart. This is going to be negative 2. This is going to be 4. The middle one I'll actually solve. It's going to be 2x plus 1 equals 0, minus 1 on both sides. 2x is equal to negative 1. Divide by 2 on both sides. X is by itself now, and it turns out that x is equal to negative 1/2, which is negative 0.5. Okay? Now to draw an approximate graph, I need to take into account one thing, which is, what's the sign of the largest term going to be? Well, the largest term is going to be made up of x times 2x times x. So that's going to be a 2x cubed. So it's degree 3, and it's positive. And that's the largest term. Now that tells me what the graph is going to look like. I'm going to draw my x-axis and my y-axis. It's going to have roots here at 4, at negative 0.5, and at negative 2. Because it's positive, it's going to be up on the right-hand side. Now we follow this back. Right? Follow it back. Okay? And that's what it's going to look like. Alright, now the next question. Next question, part C, says, at which values can the function change from being positive to negative and from negative to positive? So at what values does x, or at what x values does the function change from negative to positive? So what I'm going to do is I'm going to use a highlighter, because, you know, I'm fancy like that. I've got a couple of tools. So the bottom here is going to be red. This is the negative part of the graph. Agreed. And this up here is the positive part of the graph. So if I'm following my way along the line, like let's start here on the bottom left, we're in the negatives, right? So I'm negative, 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 turning point. Now it's positive, right? So positive, 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 sign change, okay, from positive to negative. So negative, 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 changing point from negative to positive, and now positive, positive, positive the whole way up. So what are my points at which it changes from positive to negative and negative to positive? They're the roots. So the answer to C is actually just the roots. And you could rewrite these if you want. I'm content to just say that it's the roots, but you can rewrite those three numbers if you want. Negative 2, 0.5, or negative, and positive 4. Question part D says, to sketch a graph of f of x, the function of x, we need to consider whether the function is positive or negative on the 4 intervals. Why is that? Now, let me change that into common English for you. Why do we care whether the graph is positive or negative between the roots? Why do I care? And there's a couple reasons. If we didn't, the graph would be wrong, first and foremost. The regions would not give you full credit for that because the graph would be wrong. 2, the end behavior wouldn't match up. Is it correct that it's up on the right? Well, if you didn't get the rest of it right, then maybe not. And the important one, the implication, right, the important one that's contextual, is that any predictions that we could make from this graph would be wrong. So let's take a look back at one of our earlier examples. the very first one from today, talking about Joe's landscaping company. Now, why do I care what it does in between the roots? If I just had the roots, would that be okay? Well, we already know the story. We talked about it in class. Joe took out a loan, right? Joe was in debt. He made his money back. He paid back the loan. He made some money and lost some money. He took out another loan, and his business rebounded, and it looks like he's on the way up. Now, if I didn't know any of that, right? Like, let's say I didn't know what the function looked like in between the roots. So let's just get rid of this function. And we want to focus only on the roots. If I showed you this graph, and I showed you the roots, do we have any idea what happened to Joe? Do we have any idea what his story looks like, whether he's currently making money or losing money? Do we have any idea what any of this means if I just drew something random on here, right? So like, all right, Joe's losing money. I can follow it around like this. Is this the same story? Joe started off with a positive amount of money, lost it. No, it's completely different. So if I don't know what's going on in between, then I don't understand the scenario. And Joe will never know, is he losing money or is he making money in the future? Right? That's a prediction that we would be able to make from this graph. But if you take away the line, if we don't know if it's up or down in between all these points, then we don't know that. Okay? So that's really important. Lastly, part E. All right, we've knocked all these down. How can we tell if the function is positive or negative on an interval between x-intercepts? So how do we know if it's up or down in between the roots? There's a couple ways to do that. And I highlighted them different colors. I'll just leave them that way. I'm not going to change them back. You can start with the right-hand end behavior and follow it back to the left. So start, is the right side up or is it down? And then follow that back across the graph. We've done that. That's the way we did it in class. You could also, in yellow, you could graph it in your TI-83 or 84 calculator. And just look at the graph and see what it looks like. Or you could pick an x value that's between the roots, plug it in to the function, evaluate it, and see whether it's positive or negative. I'll give you a real quick example of that. If I go back up to my earlier graph, you'll notice that in this interval between here and here, it is negative, right? It's negative the whole way through here. So if I wanted to pick an x value, right, like let's say I wanted to pick this x value, which is 0, and I wanted to plug it into the function. The function is x plus 2, 2x plus 1, x minus 4. Now if I didn't know if it was up or down, let me just plug in the 0. 0 plus 2, 2 times 0 plus 1, and 0 minus 4. Here's what I get. 2 times 1 times negative 4. And that is negative 8, which is negative. So for the x value of 0, I got the y value of negative 8. Therefore, in this interval, it must be down. Okay? If I zoomed in enough here, right, at x equals 0, the y value should be negative 8. It's down 8, right? So it must be below the x-axis there. So that's one way you can plug in if you're not necessarily sure, if you don't have a calculator and you don't really remember the rules. Okay? Just a tip for question number 21. I gave you this in class, but in case you missed it. When I say largest number of relative max and mins, by relative max and mins, I mean turning points. For the last two columns, actual number. To find the actual number, you want to graph. And by that I mean with either your TI-83 or TI-84 calculator, or you can use an app called Desmos, D-E-S-M-O-S. Okay? If you have any questions, please feel free to contact me or catch me in the morning. See you tomorrow.